Hello everyone, this is Kisle from Edureka, and today we'll be discussing about PySpark Dataframes. So let's have a quick look at the agenda of today's video. I'll start off with why exactly do we need dataframes. Next we'll learn what dataframe is and have a look at some of the features of dataframes. Then I'll show you guys how to create dataframe from various sources. And I'll finish off this video with two amazing use cases which will help you understand dataframes better. So I'm sure you might be wondering why exactly we need dataframes. Now, the concept of data frames comes from the world of statistical software used in empirical research. Data frames are designed for processing large collection of structured or semi-structured data. Observations in Spark data frame are organized under named columns, which helps Apache Spark to understand the schema of a data frame. This helps Spark optimize execution plan on these queries. Now, data frames in Apache Spark has the ability to handle petabytes of data. It can handle large amounts of data, which are usually the big data. Now it has support for a wide range of data formats and sources. We'll learn about that later in this video. And finally, last but not the least, it has API support for different languages like Python, R, Scala, Java, which makes it easier to be used by people having different programming backgrounds as well. Now another important feature of DataFrame is that the DataFrame API usually support elaborate methods for slicing and dicing the data. It includes operations such as selecting rows, columns, and cell by name or by number, filtering out rows, and many other operations. Statistical data is very unusual and very messy and contain lots of missing and wrong values. So, a critically important feature of DataFrame is the explicit management of missing data. Now let's understand what are data frames. Now data frames generally refers to tabular data, a data structure representing rows, each of which consists of a number of observations or measurements, which are known as columns. Alternatively, each row may be treated as a single observation of multiple variables. In any case, each row and each column has the same data type, but the row, which is the record, data type may be heterogeneous, while the column data type must be homogeneous. Data frames usually contain some metadata in addition to the data, for example, the column and the row names. Now, data frame is like a 2D data structure, similar to a SQL or a table in a spreadsheet. Now, there are a few important features of data frame that we must know of. First of all, they are distributed in nature, which makes it highly available and fault tolerant. Now, the second feature is lazy evaluations. Now, lazy evaluation is an evaluation strategy which holds the evaluation of an expression until its value is needed. It avoids repeated evaluation. And lazy evaluation in Spark means that the execution will not start until an action is triggered. And in Spark, the picture of lazy evaluation comes when the Spark transformation occurs. Transformations are lazy in nature, meaning that when we call some operations, it does not execute immediately. Spark maintains the record of which operation is being called through DAG, which is the directed acyclic graph. Since transformations are lazy in nature, so we can execute operations anytime by calling an action on the data. Hence, in lazy evaluation, data is not loaded until it is necessary. Now, there are many advantages of lazy evaluation, like the increased manageability, saving computation, it increases speed, it reduces complexities, and it also provides optimization by reducing the number of queries. Now, finally, we can say that data frames are immutable. Now, by immutable, I mean that it is an object whose state cannot be modified after it is created. But we can transform its values by applying certain transformations like in RDD as well. Now, a data frame in Apache Spark can be created in multiple ways. It can be created using different data formats, for example, loading data from JSON, CSV, XML file, Parquet files, and it can be also created from an existing RDD, as well as it can be also created from various databases like the Hive database, the Cassandra database, and it can be also created from files which are residing in the file system as well as the HDFS. So let's have a look at the various important classes of data frames and SQL. We have the PySpark SQL.SQL context, which is the main entry point for the data frame and SQL functionality. We have the PySpark SQL.DataFrame, a distributed collection of data grouped into named columns. And we have the PySpark SQL.Column. It is for the column expression in a data frame. Similarly, we have the same for the row. And next, we have the PySpark SQL group data, which is the aggregation methods returned by the dataframe.groupby. Now we'll learn more about these important classes later in the video. So let's go ahead and create some data frames. So now I use Jupyter Notebook instead of the PySpark shell, as I personally find it easier to work with it. Ultimately, it comes down to your choice. So guys, let's go ahead and start the demo. Now to start the PySpark shell, all you need to type in is PySpark. When you have configured the Spark in your virtual machine or your personal computer, there's few lines of code which you need to add to the bash rc file if you want the Jupyter Notebook to be integrated with the PySpark. So I've done that. I'll show you later how it works. So as soon as I enter PySpark, instead of going to the PySpark shell, I am redirected to the Jupyter Notebook. So as you can see here, guys, it has opened the Jupyter Notebook for me. So here I'm going to select a new Python 2 file. So firstly, we'll create an example data of departments and employee. So I'll show you how it's done. Now the first and foremost for the data frames is to import the PySpark SQL. Okay, now that the import is successful, so as you can see, I'm creating an employee database with the row function. So basically the rows will have the column name as the first name, last name, email, and the salary. Now next I'm going to create some of the employee data. So as you can see, I've created 5 employees with the employee data in the same format as given in the first name, last name, email, and salary. And these employee 1, 2, 3, and 4 are all in the format of the employee. Now that we have created employees, let's go ahead and create the departments. Now, as I was saying, Python is very easy and data frames are easy to use. I'll show you how easy it is. Suppose I want to look at the values of the employee 3. All I need to do is just execute the command print and use the employee 3. As you can see, we have a row in which the first name is Muriel, the last name is not specified. We have the email ID and we have the salary. Now suppose we want to see what was the row value of the employee which we created earlier. As you can see here, if I do the print employee and in square brackets if I write 0, it's the first name. So basically here I'm using the row function to create the employees and departments, and now we'll create the department with employees instance from the departments and the employees. Now here as you can see, I didn't even use the curly braces. All I need to do was type in print and department 4. Now whatever was in the department 4, which is the ID and the name being the name of the department, we have 901234, which is the ID of the department, and the department of the name is the development department. Next, we'll create data frames from a list of rows. So guys, this is where it gets a little trickier. Here as you can see, we have used the spark.create data frame. This will create a data frame DFrame. Now it will contain the departments with employees 1 and the departments with employees 2 instance, which in turn have the department of 1 and department 2, where the employees are employee 1, 2, and 5 in the department 1, and we have the employees 3 and 4 in department 2. So if we display the DFrame, we'll see we have the department, and inside that we have a string and the name, and then we have the employees. It's an array as we have given here, which has the first name, last name, email, and the salary. So guys, this is how we create a data frame. Now let's have a look at a FIFA World Cup use case. I hope Argentina recovers from the Croatia match too. So here we have the data of all the players in the FIFA World Cup. Let's go ahead and load the data. Here we have the data in the CSV format, so I'll show you how it's done. So I'm going to select a new notebook for this one. So as you can see here, we have the FIFA_df, and I'm using the function spark.read.csv. This will take the data from the CSV file which is provided in the file path, and I've set the info schema as true and header as true. Now if we don't set these values to true, usually the first row of any database has the name of the columns. So what will happen, it will not infer the schema and it will take the first row as the values of the data frame. So as you can see here, the path by default, it takes the HDFS path. So in order to give the path of the local file system, you need to put in the file : and double forward slashes. Now that we have the data frame in FIFA_data_frame, let's see how this data frame looks. So as you can see here, we have the round ID, the match ID, we have the team initials, the coach name and the team they belong to, we have the lineup, we have the player name, we have the position it placed, and the event. Now if you want to print the schema of the particular data frame, all we need to do is use the print schema. And as you can see here, we have the round ID, which is integer, match ID is also integer, team initials are string, and here we have the option of giving the nullable as true. So even if there is no value specified, it will take the value as null. Now suppose next I want to see what are the column in my data frame. We saw that earlier when we used the show command, but another way to do that is using the dot columns. So if you want to know the amount of rows or the number of records in our data frame, all you need to do is give the name of the data frame and use the count function. So as you can see here, we have almost 37,000 rows. Now if you want to take a look at the number of columns, we can manually count it, but when it's not possible, we can use the length of the columns function. So as you can see here, we have the 8 columns and we have 37,784 rows. Now suppose we want to describe the summary of a particular column, we use the function describe. Now what it does is that it gives a summary, that is the count, that is 37,000, which is the number of rows. We get the mean of the particular column which we have given. In our case it's null because it's in the string. We get the standard deviation, we get the minimum. Now here minimum is according to the alphabetical order, so we get Acosta Nielsen, and maximum is Sqoop. Now similarly we can describe the column position also. As you can see here, we have only count of 4,143. The mean and standard deviations are null, and the minimum value is C as the captain, and the maximum is goalkeeper captain, GKC. Now suppose you want to know the player name and the coach name in a particular format. We just need to use the select option and specify the column names here. As you can see, we have the player name and the coach name. Now there is another function in the data frames, which is the filter function. Suppose we want to filter out all the players and all the data according to the match ID. We use the filter function here. And on top of that, we use the show function to get our desired results. So as you can see here, all the data which we have is for the match ID 1096. So it's showing only 20 top rows. Now similarly, you can see that if we want to filter according to the position of captain, here we have our result. And if now I want to check that how many records I have in this particular data frame in which the position is given as captain, you can see we have 1510 rows. I'd rather say the records where the position is defined as captain. It's very similar to SQL. We'll see how we can import SQL queries also later on. Similarly, if we filter it using the position of GK, which is the goalkeeper, you can see we have all the records. Now we can use the filter on more than one parameters also. So here I've taken the position as captain and the event as G40. So here we'll get result of all the players who are paying position as captain, and the event they participated was at G40. So there were only two results here. Now that we have seen filter and select, let's go ahead and see how we can order or group it. To order, we use the order by function here, and here we are ordering it according to the match ID. So as you can see, the lowest match ID was 25. It usually goes in increasing order. You can also change the parameter of ascending as false to get a desired descending order result. Now here I am registering a temporary table of FIFA_table for the same data frame which we had earlier, which is the FIFA_df. And now I'm going to use the SQL queries here. So as you can see, using the SQL context, I've passed the function, or as rather say the command, which is the select asterisk from FIFA_table. This will give us the same result as FIFA_df.show, as the same data is now converted into a table which can be used in a SQL context. So here in this SQL context, we can pass any type of SQL queries that we wish for. We'll see that later in our different use case. So I hope you guys understood what the basic functions, the basic filtering, the order by, select, show, group by, all of that can be used in the particular data frames. And you also saw how we can pass SQL queries also here. I'll show you. You just need to invoke the SQL context.sql. And inside that you can give your SQL queries to be executed on the table, rather I'd say, because the data frame has been converted into this table FIFA_table. So now that we have seen how to create a data frame using a CSV data file and also apply some of the functions like selecting, ordering, filtering, and also passing SQL queries to that data frame, let's go ahead with another amazing use case, which is the superhero use case. So here we have the data of all the superheroes. Nonetheless, I'll show you that one too. Let me load the dataset again. This dataset is also in a CSV format, so we'll use the same method here to get the data in. So as you can see, the data is in a CSV format here, the superheroes.csv, and we'll load the data frame in the same format. So guys, keep in mind that if the top row of the data set or the data frame which we are using has all the column names of the data set, please make sure you use the info schema and the header as true. So guys, as I mentioned earlier, you can use the show command to see the contents of the data frame, but you can also specify the number of rows. So here, in case if I have specified show 10, that means that it will show me the top 10 rows of the particular data frame. As you can see here, we have the serial number starting from 0 to 9. So let's have a look at the columns. The columns here, we have the serial number, we have the name, gender, we have the eye color of the particular superhero, the race to which it belongs, alien, or is it human, Hungarian, cosmic entity. We have the hair color, we have the height, with the publisher. And now there are various publisher of these superheroes like Marvel, DC, Dark Horse, NBC. We have the skin color of the hero, we have the alignment, and we have the weight. Now if we use the print schema, we can see which all columns have what all data types associated with it. Say for example, race is a string. You can also set nullable as true and false, as I mentioned earlier. Now let's filter out this with using the filter function, and let's see how many male superheroes we have. We have 505 male superheroes. And let's see how many female superheroes we have. 200. So here I'm creating another data frame, which is the race_df. Now what it'll do, it'll take the superhero data frame and first it'll group by using the race, and then it will provide the count to that particular race. So as you can see here, we have the race and associated count to that particular race. It's showing only the top 20 rows, but I guess there are more race of superheroes than we expected. It's not the same as we see in the comic books, is it? Now if we create another data frame here, we are creating the skin_df, which will take the superhero_df data frame and will group by according to the skin color, and it will also provide the count of how many superheroes have that particular skin color. So as you can see, we have 21 green superheroes, we have 5 gray superheroes, we have certain red and golden superheroes, but majority of them are not specified, which is 662. So this is one of the benefits of using a data frame, as in you can provide null values too to your data sets. It doesn't provide an error. So till now we have seen group by and order by. Let's go ahead and see the sort function. So I've created weight_df, another data frame, and I'm going to sort it according to the superhero weight, according to the weight column which is mentioned here. And I'm using the DESC function, which stands for descending. So as you can see, we have Sasquatch, which is male, eye color red. And if you finally look at the weight, we can see the weight is 900. I mean, whatever be the unit of that weight, it's the highest. It's 900. Now I've created a DC_hero to filter out all the heroes from the DC comics. And if I want to see the count of how many heroes are there in the DC comics, we have 215 heroes which are in the DC comics. And similarly, if you want to have a look at the heroes from the Marvel comics, all we gotta do is use the filter function along with the publisher as Marvel Comics, and same we can do as is Marvel_hero.count. So you can see we have 215 heroes from DC and 388 heroes from Marvel. Now if you want to have a look at all the publishers and get a count on how many heroes are there in the publisher, we're going to use the group by function along with the count function. So you can see here Marvel Comics has 388. This is another way of seeing how many superheroes are there. And DC Comics has 215. Personally, I feel that DC has much better storyline than Marvel, but still. As you can see here, Image Comics has 14 and the null values has 15. So we can say that Marvel and DC are the two major contenders in the superhero comic market. Now here I'm going to create a table of superheroes using the data frame superhero_df, and similarly I'll show you how to pass SQL queries. Now the select asterisk from superhero table, this is equivalent to what we use in superhero_df.show. The output of this one is not in a very good sophisticated manner as it was for the data frame. Now if we pass the SQL query as select distinct eye color from superhero table, let's see what the output of this one will be. Okay, we got the list of all the different eye colors, which are the distinct eye colors. We have yellow without, violet, we have gray, green, yellow, brown, indigo, silver, purple. Now suppose I want to see how many actually eye colors are there, distinct eye colors. So we have 23, which we have the distinct eye colors. We saw earlier that maximum weight was 900 pounds or 900 kilos for a particular Sasquatch. As you saw earlier, here you can see this one. So we can get the same result from SQL as well if we choose the select maximum given the name of the column which we want, which is the weight from superhero table. Although it will give us only the maximum record, but it will be the same. So as you can see, the maximum weight is 900 units. So guys, these are some of the functions and the features which you can use in the data frames. And as I mentioned earlier, data frames are very important as they are used for structured and unstructured data, and it can load petabytes of data which is useful for big data computations. And most importantly, it is used for major slicing and dicing, which is clearing out and cleaning the data set. So guys, I hope you enjoyed this session on data frames in PySpark. So if you guys have any comment related to this video or you have any question in mind, feel free to ask in the comment section below. Thank you so much.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!